Hello students, good afternoon all. Welcome to another video lecture of PPL, Principle of Programming Language. Today we'll discuss about modeling language properties. Language is nothing but the medium of communication, or the language is nothing but what a system understands from the user. A language must have some properties like a proper syntax, semantics, and writing format. But modeling a language means the way it implemented, or during the implementation, the way it is modeled to get the proper desired user output, such as to design a particular flowchart or analysis, we need a particular UML, that is called modeling language properties. So we'll study about modeling language properties. As you know, I am Ashish and I have the experience on security of 17 years and different paper has been published on journals. So move to the outline of this lecture. We'll study about importance of modeling language, different type of modeling language, as you know, semantics and expressiveness. This is quite interesting on this topic. So moving to the next, the type of modeling language. So here different types. So these are some types which are specialized and that is used to describe, simulate and analyzing model of system or processes. So some of computer modeling languages are mathematical modeling language, simulation modeling language, agent based modeling language, system dynamics, and FEM, that is finite element modeling. Then BPML, business process modeling language. More or less, you all know what is mathematical simulation and BPML. We'll see everyone in detail. So starting from the mathematical modeling language. So first one is MATLAB. This is mathematical laboratory. It is used for numerical computing and developing algorithms, widely used in engineering and scientific research. In computer science, we mainly use this MATLAB for any simulation, for any data set experimentation, time duration taken by any program, execution, and efficiency. It is widely used in ML and DL. Next one is R. It is mainly used for statistical modeling and data analysis, popular in bioinformatics, economics, and social sciences. And Octave, the open source alternative to MATLAB. Of course, MATLAB is a paid one, so Octave we can use it as open source, used for numerical computations. So have a go through on this slide, then we'll move to the next one. Okay, moving to the next one, the simulation modeling language. So this is the second one. I missed that point. Simulation modeling language. Here, the first one is Simulink, an extension of MATLAB using for modeling, simulation, and analyzing dynamic system, commonly used in control engineering and signal process. And of course, it is used in engineering, control engineering, signal processing, electrical, electronics, like this. Then Modelica, it is a OOPS oriented modeling language. We generally solve the different complex problem involving mechanical, electrical, electronics, hydraulics, fluid engineering, thermal control, electric power, process-oriented subcomponents, and more or less this can help in multi-domain modeling language. And VSDL used for mainly electronics or chip component based development language. So generally it is used in electronics and telecommunication. Then Verilog, it is a hardware description language very similar to VSDL. It is widely used in design and verification of digital circuit. And agent based modeling languages, these are called NAT, Logo, AnyLogic, and Repast. Agent based means it provides a particular language for a particular programming environment. For example, if you need Java environment, it provides you a particular uh, storage area or particular IDE for which Java can be used as and feel like as Java. If you use a low memory program, it can also provide that IDE. So used for simulating natural and social phenomena. Then AnyLogic, it is a simulation software agent based, and Repast, a family agent based modeling platform. Then system dynamics modeling language, Stella, a visual modeling tool used to build and simulate system dynamics model. Then Vensim, this is a simulator who normally used to um, validate different softwares. Suppose you develop a software, you want to validate that, you want to analyzing that, packaging high quality dynamic feedback model. Mm, More or less this can use to take the feedback and different aspect of a software. And PowerSim, similar to Vensim, used for modeling simulation analysis of dynamic systems. Then FEM, finite element modeling languages, ANSYS, used for finite element analysis, computational fluid dynamics, and other type of simulations. Abacus, it is same as FEM, same as mechanical simulation modeling technique. It also doing component and assembling. And Cosmol Multiphysics, it is also a simulation platform covering physical based simulations. Next one is BPM. More or less we are using it such as UML, Unified Modeling Language. It is a general purpose developmental model language in the field of language engineering, intended to provide a standard way to visualize the design of a system. So normally business process model and notation, they are used in a graphical way just to represent how much process has been done on a particular problem. And normally statistically it's shown in a chart model that whatever processes has been done and how much it is there in a business process model. And in computer science we normally used to represent it in UML, Unified Modeling Language, how to develop and what to develop and how the variable has been redefined. Next one is coming to what is a modeling language and how it is defined. And we already know the types of modeling language and importance of modeling language. Moving to the importance part, the modeling language more or less include syntax. What are the syntax element? What are the syntax definition, how the structure has been integrated with the syntax, and how this syntax has been modeled so that the language can be easily written by the end users. And the way we are studying the grammar in automata like a b b c c, the way we are defining the grammar that is used to define the syntax of a language, the syntax of that of a language defined in so well manner that can be um, implemented easily on a particular compiler based on the IDE. The syntax then um, provide the syntax that provides the format that must obey the semantics. That means the way it is construct and the meaning is defined for that particular statement. So semantics is two type: operational semantics and de- denotional semantics. Operational semantics means the process actually happen on a particular syntax, and denotional means the operation that what we write on a particular semantics that must be denote the things by which the operating system, the compiler, the data and the user, all fours are uh, integratedly sharing the data. Okay, next moving to expressiveness. So whatever modeling we are using, whatever language we are using, that particular thing must able to express its existence, express its logic, express its semantic or syntax to the user in a clear and simple manner, so that the user can able to express his or her code on a particular way, syntax or semantically correct with the computer, so that that language can be studied, can be learned, and that language can be used to develop a particular software. So expressiveness refers to the ability of modeling language to represent different concepts and ideas. And secondly, domain specific language. For example, what we know that MATLAB. MATLAB is a software by which we can do complex calculations, and we can generate graphs, we can generate 3D photos for a given data set, by which we can find out the performance index of that particular algorithm, a particular code. So the efficiency measurement can be easy using that particular MATLAB. So in the form of expressiveness, a language must be domain specific language. If it is a MLDL, we can able to do it through MATLAB. If it is a security form, we can able to map through it a Metasploit or Mmap or some other simulation, by which we can get the um, different output of a different domain. That must be a general purpose language as our third uh, point is concerned. This one. Okay. Moving to the next. Why this expressiveness? And before that, the syntax and semantics are required. That builds the abstraction. What is abstraction? If we consider the data abstraction, to consider the data abstraction. Data must be abstracted in any language or any model, and data must be written by that particular model, so that it is called as model driven development. Whatever model that is, the data should not be corrupted, and the data should not be uh, puzzled or confused by that model. Data must be provided at the right time to the authorized user, and the data must be provided um, as the program goes to an end. The model by which we develop that particular program, that model must be use the data in a way that it should help the user to develop the particular or desired application. Then second point is abstraction allows for simplifying complex concept and focusing on relevant details. If we take example of a student database, in a student database, the complex concept is suppose a student is there and the person is having some of sorry marks of 5 semester, and last semester and rest 3 semester he has some back paper. So in that case these datas become complex concept because let's say the roll number is 5, so data must be abstracted to roll number 5. So when this is back paper for that particular student, a ERP must be developed by which this should be shown as the back paper, and the mark of this particular subject can be updated or can be inserted after a while by the abstraction process. Then the third one is level of abstraction. Level of abstraction means in OOPS concept we need one type of data abstraction. We have already studied the data abstractions. Then level of abstraction means on what uh, level we can able to provide the data to the user, or you can say how to describe a particular data so that it can be viewed by the programming language in very easy manner, whereas originally it is complex. So we can say level of abstraction is a way to describe how much complexity is involved in viewing or programming a system. A system level of abstraction can be described by its level, such as if we consider the DBMS, is such as physical level, logical level, and view level. Whatever we are viewing, that is the view level. Physical level means the in the form of storage area, and logical means the way we are query the data. So, in DBMS point of view, the data abstraction is in that way, and in programming point of view, how complex it is and how data can be provided. Moving to the next, the extensibility. Extensibility is nothing but a particular technique which refers to the ability to customize and add new features to the modeling language. This is nothing but updating the modeling language day by day whenever the technology changes so that our models cannot be outdated. We can use that models, or we can say like a data which can be used several times or several part and automatically updated, that is the superior data. We can know the metadata also. Likewise it has also meta modeling, and it provides the extension to add new languages into the model so that the extension can be done for that model for other languages, and this model can provide support to the particular model. You can take the example of C language and Java language in a integrated or combined IDE such as CodeBlock, VS Code, etc. If we consider metadata, so metadata is nothing but the data which describe the subdata. And if we consider a model, when a model is already defined and it is already defined for the particular language, and that particular model is assigning, or that particular model is implementing another language for a particular ID for the same language, then it creates a particular ID for the updated language for the user. You already work with code block, so you can find the difference between this implementation modeling and language extension. Like in code block, we already we compile the C program and C++ program in the single compiler, and we also do Java compilation and Python compilation in a single compiler. So if that particular code block model is not allowing the different ID, how this extensibility can be achieved, or extensibility can be verified, or extensibility can be justified for that particular model implemented in code block. Clear? Moving to the next, the tool support. As it is a modeling language development and uses, we need some tools to develop that particular language as per the required standard, as per the user goal. And whenever we are starting the implementation of that modeling, implementation of that model into a language, we need some modeling editor, some changes we need to do on that model, and finally we need to code that particular uh, algorithm on that particular language based on that model. So we need a code generator also. Okay, till this you all understand. The tool support is nothing but it provide a tools for the development environment by which we can edit the program codes, or we can regenerate the codes as per the requirement of the user, as per the requirement of the models. Moving to the next, standardization. जब भी हम एक मॉडल में काम करते हैं, whenever we are working on a modeling thing, हमें एक स्टैंडर्ड फॉर्मेट फॉलो करना पड़ता है by which that model can be accepted worldwide, or that model can be accepted for other languages, so that that models can be implemented by uh, more organizations, that models can be um, used by more or more users. That's why we need a standardization of this particular modeling language, by which the importance for this standardization has been increased. Why importance of standardization is there? Because if there is no standardization, there can be a problem of degrading the implementation standard, and implementation can be going wrong or erroneous. The benefit of standardization, if we provide a particular standardization context to the modeling language, it gives you a environment by which standardization can be achieved, and once it is standardized, it provides other language, other users a particular environment to build a model or implement that model. If we think on a global aspect, the benefit of standardization apart from the computer language, it gives a uh, different varieties of product source or implementation path, and it decrease the volume of product in the store. If we consider in the computer language, then it provides a global area to store our program on a clouds. Then we can use this particular thing to facilitate different cloud phenomenon and different security expectation also. Okay, this standardization of model is very important. Why? Because it allow different system to exchange data consistency. Without standardization, it would be challenging for different systems to communicate with each other and exchange data. That's why that model must be standardized, and that standardized must be implemented to a particular language to justify the standardization over in a global aspect. Let's have a case studies. Example of modeling language in use. First one is UML and SysML. So, so what we are doing in UML? UML we are generally used as a designing language features, because it is the unified modeling language by which you can able to find out how a data flow on a particular um, logic. So we can create a general purpose visual modeling language that is intended to provide standard way to visualize the design of a system. So normally this UML helps software developer visualize and construct, document new software system and blueprints. If we are not able to see the blueprint, how it is going to be लुक लाइक आफ्टर द इम्प्लीमेंटेशन, कैसा दिखेगा अगर हमको पहले से अगर हम विजुअलाइज नहीं कर सकें, तो हाउ कुड वी एबल टू मॉडल दैट पर्टिकुलर लैंग्वेज. ओके, तो वही चीज़ है. तो इसको देखने के लिए हम वी नीड टू विजुअलाइज दैट थिंग. सो मॉडल क्या काम करेगा उसको पहले से ही डिफाइन करके स्टैंडर्डाइज करके हमें काम करना पड़ेगा. ओके, then at last the model should be future prospect oriented. फ्यूचर ट्रेंड में भी वो मॉडल काम करना चाहिए. एंड एज वी आर ओनली dealing with the properties. Okay, so it should be different type of modeling languages and importance of modeling languages. Okay, this concept is somehow conceptual thing, somehow uh, theoretical portion. So with this particular video, go through with the books, go through the books, go through different articles they are in the internet. Okay, you can get maximum articles, go through it. Regarding exam point of view, you will get questions from types of modeling languages what we have already discussed, and if any other doubts, do revert back to me. We'll discuss in class. Okay, thank you. Have a nice day.